In this video, we're going to talk about dot plots and histograms. This is an example of a dot plot. Dot plots are good because they show each item of numerical data above a number line or horizontal axis. It makes it easy to see the gaps and clusters in the data set, as well as how well the data spreads along the x-axis. However, they are not very practical when you have a lot of different values. So example 1 says the students in one social studies class were asked how many brothers and sisters or siblings they each have. The dot plot here shows the results. So in the dot plot, we can see that the lowest the number of siblings that someone had was none, and the highest that they had was 6. So A says how many students have 6 siblings. So we go to 6, see how many dots we have. We have 1, so we had one person that had 6 siblings. How many students have no siblings? So we go to 0, we count and see how many dots we have. We have 3, so we have 3 students with no siblings. On C, it says how many of the students have 3 or more siblings. So 3 or more siblings means that I'm going to have to do 3, 4, 5, and 6, and I'm going to have to add them all together. So I'm going to count how many have 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 for 4. None of them have 5, and one of them has 6. So then I just add them up. 6 plus 4 is 10, plus 1 is 11. D says, what is the mean of the data? So to calculate mean, we're going to go to calculator. We're going to go to stat and edit. Clear out anything that might be in L1, L2, or any of your other lists. And then you're just going to add this information to your calculator. So on 0, I've got 3 that have 0, so I'm going to do 3 zeros. I've got 3 that have 1, so 3 ones. I have 3 that have 2, so 3 twos. I have 1, 2, 3, 4, 5, 6 that have 3. And then I've got 4 that have 4. None that have 5, and 1, 6. So now my calculator will easily calculate mean and median, so question D and D, by doing stat calc, 1 bar stats, use L1, go to calculate, and I need to get X bar, which is the mean, and so X bar is 2.45. What's the median of the data? So scroll through and look for the one that says MED. MED is 3, so the median is 3. Seven says the resting pulse rates were recorded for 16 boys in gym class before they exercised. The line plot here shows the results. A says what is the range of the pulse rates? So the range would be the maximum number minus the minimum number. So the maximum number is 85 minus the minimum number, which is 79. So you would do 85 minus 79. When you do that, you get 6. B says, how many boys had a pulse rate over 81? All right, to find how many have a pulse rate over 81, we're going to count how many had a pulse rate at 82, 83, 84, and 85. So at 82, there are 3. At 83, there are 4. So that's 7. And then 2 at 85. So that makes 9. C says how many boys had a pulse rate of 83, and that would be 4. B says what is the mean of the data, so we need to go to the calculator. And go to stat, go to edit, clear out L1. We've got 2 79s. We have 4 80s. One 81. 3 82s. 4 83s. And 2 85s. Then go to stat, then go to calc, 1 bar stats. L1 is your list. Go to calculate. So you get your X bar or your mean at 81.69. And the median, 82. F says what is the standard deviation? So we can choose to do the sample standard deviation or the population standard deviation. Let's go with the population, so let's do 1.86. Three says the heights of 20 basketball players in inches are given below. Make a dot plot using the number line below. So at 68, basically we're going to go through this and put a dot everywhere they should go. So 1 at 68, we've got 2 at 70, 1 at 71, 75, 80, 81, 82, 84, 75. So we're going to start stacking. Another 75, another 80, another 75, 77, 75, 80, 83, 80, 71, 70. B says, what is the spread or the range of the data? So whenever you're doing the range, you're going to do the biggest number, which is 84, minus 68. So when you do 84 minus 68, $16. C says, what is the mode of the class or the data? So we're going to look and see which one has the most dots, and that would be 75. D says, how many players are greater than 70 inches tall? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We're going to move to histograms now. So at this point, you should pull out the notes that the sub gave you on histograms. So for histograms are going to look like this. They are useful for large sets of data, and they look kind of like a bar graph, but each bar touches the one that's next to it. So a bar graph would look pretty similar to this, except your bars would not touch. They'll have a little bit of gap in between them. All right, number 1 says the histogram shows the heights in centimeters distribution of 30 people. A says how many people have heights between 159.5 and 69.5. So we go and find where 159.5 and 69.5 are, and that would be 7. B says how many people have heights less than 159.5. So 159.5 is this line right here, this bar, and so that would be 9 and 6 more, that makes 15. How many people have heights more than 169.5? So this is 139.4. Anything from 139.4 to 149.5. This starts 149.5 to 159.5. So we need to find more than 169.5. So this is 159.5, this is 169.5. So we would be looking at these two bars here. So that would be 2 and 1 more, that makes 3. D says what percentage of people have heights between 149.5 and 179.5? So we're going to be looking at this, this, this. So we have 9, 7, and 5. So 9 plus 7 would be 16, plus 5 would be 21. So we would do 21 out of 30, and that would give us a decimal, and we can turn it into a percent. So 21 divided by 30 gives us 0.7, so that would be 70%. The histogram below shows the efficiency level in miles per gallon of 110 cars. A says how many cars have efficiency between 15 and 20 miles per gallon. So that would be this bar. That would be 35. How many cars have an efficiency more than 20 miles per gallon? So we would go and find where 20 is. So this would be anything 5 to 10. That would be anything 10 to 15. That would be anything 15 to 20. So we'd be looking at this one and this one. So we'd have 25 and 15, which would be 40. What percentage of cars have an efficiency less than 20 miles per gallon? So this starts 20. We would do 35, 20, and 15. So 35 plus 20 is 35 and 20 and 15. Yep, that's right. All right, so we would do 35. We would say that 15 and 20 make 35, and 35 plus 35 is 70. So how many total did we have? 110. So 70 over 110. So that gives us 0.63 so that's approximately 0.64, which would give us 64%. Number 3 says the histogram below shows the level of cholesterol in milligrams per DL of 200 people. So A says how many people have a level of cholesterol between 205 210 milligrams per deciliter. So scrolling down here, we're going to go between 205 and 210. So that would be here. That would be 0.2. Now the problem with this is this represents on the side our relative frequency. So our relative frequency is 0.2. So because we know that there are 200 people, we're going to do 0.2 times 200. And whenever you do that, you get 40. How many people have a level of cholesterol less than 205 milligrams per deciliter? So this is 205. So you'd have 0.1 and 0.05, which would make 0.15. Because you've got 200 people, so 0.15 times 200 gives you 30. What percentage of people have more than 215? So that would be this and this. So 0.25 and 0.05 is going to be 0.30. We'll multiply that by the 200 people that we have total. $60. How many people have a level of cholesterol between 205 and 220? So this, and this. So we've got 0.2 and 0.35. That would be 0.55. And then 0.25. So you're going to do 0.80 times 200. $160.